In this set of videos, we're going to be looking at a couple statistics that measure the position of a data point. In other words, how did you do compared to other people in the population? Were you above average or below average? Were you in the top 10%? Were you in the bottom 30%? These can be interesting stats to know to kind of see how a certain data point compares to the rest of the data in that population. The first stat we're going to look at that measures position like this is z-score. Now, z-score specifically tells you how far above or below average was a specific data point. Now, a little more specifically, z-score tells us how many standard deviations above or below average was a data point. And there are two ways we can calculate z-score. Excel has a built-in formula that works, which is called standardize. And we can also just do it by hand because the formula is pretty easy. We take our data point, the value, we subtract it from the average from it, and then we divide by the standard deviation. So both of these will work. Once we get our answer, we can interpret the result in three different possible outcomes. Either z equals 0. This means our data point is exactly on the average. If z is positive, our data point is above average, and the bigger the z-score is, the more above average. And if z is negative, then our value is below average. So let's try to set this up. The first thing we have to tell Excel is, well, what is the mean and what is the standard deviation? These are values that we're going to put into this formula every time. So I'm going to go ahead and I'm going to highlight them yellow because we have to enter those every time we use this. Now, in order to actually calculate z-score, we have to tell Excel one other thing, which is the data point itself. So I'm going to go ahead and put in value here. You can label this data point or specific data point, like whatever you want to label that is fine. And then what Excel is going to spit out for us is the z-score. So this is the final value that we're going to get. And again, the formula is pretty easy for this. So let's put some numbers in here from our example so that we can kind of see the formula working in action. So in our example here, we are told we take a psychology test and an English test, and we want to know which one did I do better on compared to the rest of the class. So let's first look at the psychology test. I got an 81 on the psychology test, which had a class average of 78, so that's my mean, 78, and had a standard deviation of 5.6. Now see, we know the value was I got an 81, so that's my specific data point is 81. Now to find z-score, we said there were two formulas we could use. I'm just going to go ahead and calculate it by hand because the formula is easy enough. So equals parentheses, the value minus the mean, close parentheses, divided by the standard deviation. And there we go. There is our z-score for my score on the psychology test. Now what does that mean? Well, first of all, it's a positive number, which means that I did above average. But it's not a very big positive number. It's less than 1. So this means that I am only half of a standard deviation above average, which makes sense because I was 3 points above average, and the standard deviation was close to 6. So that's where our half comes from. So we know on this one that the psych test, I was 0.536. for my z-score. And then we can do the same thing for the English test. And this time I won't have to type in the formula separately because it's already there. So this one, the class average was 66, standard deviation was 4.1, and my score was a 74. So in this case, I actually did really well in this test compared to the class. I was almost 2 standard deviations above average. So on the English test, I was 1.951 for my z-score. So compared to the rest of the class, I did better on the English test. So even though my actual score that I got, a 74, was lower on the English test compared to the psych test where I got an 81, compared to the rest of the class, I did a lot better, right? 2 standard deviations above average compared to only half a standard deviation above average.